Hi, welcome back to Max Learning Groups. Now, today we are going to look at one of the heuristics that is not very commonly used, which is factors and multiples. So we learned factors and multiples at primary 4 level, but actually there is also a kind of a heuristic, right? This is also a heuristics that we can use to solve difficult problems. All right, so if you look at like how do we use factors and multiples, why are they heuristics? Okay, now let's look at the first example to see how we use factors to solve problem, right? Problem that looks a bit hard to solve. Miss Ong wants to pack 72 pears and 64 oranges into as many boxes as possible without any leftover. It means there are no remainder, okay, no leftover. So when there are no leftover, it means that you are looking at what? You're looking at factors, right? Factors, because when there are factors, there are no remainders, right? Like what do you know about factors? Factors are like, for example, factors of 16. So yeah, 1 times 16 is equal to 16. So there's no remainder. 2 times 8, that will be 16. So so when you see without any leftover, there's a clue over here. Without any remainder, without any leftover, then the heuristics that will come to my mind is using factors. Okay, factors to work out the answer. All right, so let's continue reading, and each box will have the same number, right? Each box will have the same number of fruits, and the number of pears in each box is the same. So find the number of pears in each box. So I know that I must use factors already. Alright, then how to do this? Now it means that I will need to find factors of 72 and 64. Alright, so and how do factors help me to get how many pears in each box? Okay, so I got 64 oranges. Alright, so let's write out the factors of 72. So you will have 1 times 72, that's what you learned in primary 4. And you always start in order. So you have 1 first, then followed by 2. 2 times 36 will be 72. So factors don't give you remainder. So when you can divide and there's no remainder, that is called a factor. And then 3 times 24 will be 72. And after 3 will be 4. 4 times 18 will also be 72. 5, that's a remainder. So it is not a factor. 6 times 12 is 72. 7, there's a remainder as well. 8 times 9 is 72. 9 times 8 repeated, right? They are repeated factors. So when they are repeated factors, you don't have to continue. So what are the factors of 64? So 1 times 64, and then 2. 2 is a factor because 64 can divide by 2. Alright, so you can see that when you learn P4, right, when you learn multiples and factors at P4 level, it actually gives you another method to solve the harder problems at P5 and P6 level. So 3 cannot, 4 times 6, 4 times what? 4 times 16, right? 4 times 16 will give you 64, right? And how about 5? 5 cannot, 6 cannot, 7 cannot, 8 times 8 will be 64, and when there's a repeated factor, you can also stop. Alright, stop all the workings. Okay, so how do the factors help you? Help you to get the how many pairs in each box. Now, so at P4, what do you know about factors? After you have found the factors, what's the next step that you need to do is to find common factors. So your 1, okay, is a common factor. Then your 2 is a common factor. 3 no, 4 is a common factor, 6 don't have, 8 is a common factor, and then your what else? 9 don't have, 12, 18, 24, and so on. So I don't think there's any more common factors already. So so if you look carefully, what are these common factors? They are the boxes. They are the boxes that Miss Ong have. Like for example, Miss Ong cannot have one box because you want to pack into as many boxes as possible. So cannot be one box. So maybe she has 2 boxes. So if she has 2 boxes, then there must be 36 pairs in one box, in each box, and there must be 32 oranges in each box. Maybe she has 4 boxes. Then there must be what? 18 pairs in every box, and there must be 16 oranges in every box. So maybe she has 8 boxes, maybe, and then there must be 9 pairs in each box, and there must be 8 oranges in each box. So each box will have equal number of pears and equal number of oranges, right? So that's how you use factors, and then after that you look for common factors. So she wants to pack into as many boxes. So which means that you look for the biggest common factor, which is the most number of boxes, and there will be 8 boxes. So if there are 8 boxes, then how many pairs in each box? Then you must have 9, right? There must be 9 pairs in every box. So your answer will be 9. So there must be 9 pairs in each box. Okay, so factors is also a kind of heuristics that you can use to solve problems like this. And how do I know when to use factors? When I see without any leftover. So when there's no leftover, or when I see the word product. Okay, there's a word over here which is also quite common. So when you see product, or when you don't see, or when you see without any leftover, or there's no remainder, then you will think of factors already, right? Factors. Okay, so these are clues to look out for, to know what heuristics that you can use to solve the problem. Okay, so let's go to the next one, and now we look at multiples. Multiples is also another heuristics, alright, multiples. So when do you use multiples? Now, there are a total of 200 pens, pencils, and erasers in the stationery shop. The pens and pencil are less than 100 each, and they are both divisible by 3 and 4. That is multiples already. It means can be divided by 3, can be divided by 4, multiples. Okay, multiples. No factors here, right? It's multiple, because multiples can be divided by 3. You're looking for multiples that can be divisible by 3 and divisible by 4. And the pen is twice the pencils, and there are fewer erasers than pens. Okay, so method, heuristics that we are going to use, multiples. So how many erasers are there? Okay, now if you are going to use multiple as a method to solve, then there is something that we should do, a table, right? We have a table to help us to list out the multiple. So together with listing, right? So when you have listing, systematic listing, you can actually use systematic listing, a table to list out your multiple. So this is how you put the methods together, right? If you want to have multiples, then you have a table to list out your multiples, so that it's easier to see. And I would like to label. So you have pens and pencils. Okay, pen and pencils. Okay, all right, and then of course erasers, right? I can put down erasers. Okay, now the pens and the pencils are less than 100 each, and they are both divisible by 3. Okay, so let's put 3 and 4. Alright, so the pens and pencils are divisible by 3 and 4. So you look for common multiple. So is there a shortcut to find common multiple? Yeah, there is. You look at the bigger number, you get the multiples of the bigger number, which is 8. Can 8 divide by 3? Cannot. So you go to the next one. 12 divide by 3? Can. So your common multiple will be 12. Right? So 12 is divisible by 3 and 4. Okay, and then you keep going, right? So you can see that the pens is twice the pencil. So 12 and 12 is not twice as many. So what do we do? Okay, then you may want to, pens is twice the pencil, so you times 2 to get 24, right? 24 pens and 12 pencils. But if you look carefully, there are fewer erasers than pens. So if you think smartly, alright, there is a total of 200. Okay, total of 200 stationaries. So if you take 200 and you minus 24 pens and 12 pencil, that will give you 100 over erasers, which is not fewer than the pens. So which means that too small, right? The pens and the pencils are too small, right? They are small. You need to increase them. Okay, so how to increase them? So you get your common multiple, right? So there's some guess and check over here. So you have to increase them, and then keep increasing them, right? So 24 times 2 will be 48. So now 48 is twice the pencil. And if you take the total and you minus 48 and minus 24 pencils, that will give you how many erasers? So 200 minus 48 pens and minus 24 pencils, that will give you about 128 erasers, which is still more erasers than pens. But we don't want. We want fewer erasers. So there is a little bit of guess and check. Okay, a bit of guess and check here. So what do? We have to continue to increase the pens and the pencils. So let's erase this 128 and let's increase the pens and the pencils. So maybe 48 pencils for and then the pens, I double it, become 96 pens, and 48 pencils. So the pens is twice the number of pencils. Okay, and then how many erasers will there be? You take 200 minus 96 and minus 48, and you will get 56 erasers. Okay, 56 erasers. Okay, so let me use my color, my red color. So so I have 96 pens, which is twice the pencils, and I have 56 erasers, which is fewer than the pens, which is true. 56 is fewer than 96. So how many erasers are there? So my answer will have to be 56 erasers. Okay, so that's how I use factors and multiples to solve problems like this. So factors and multiples are also considered as a method, as a heuristic to solve questions on this. Of course, there will be some clues that you need to look out for in order to know whether you can use factors. Like for example, when do you use factors? When you see the word product, product, or when you see a remainder, or whether there's a remainder, or if you see a question that says if you see something like this without any leftover, or whether there's a leftover or there's a remainder, you can actually use factors. Okay, factors to solve. And when you use multiples, when you see phrases like can be divided, can be divisible by 3, divisible by 4. Sometimes the problem may also give you things like bags of the apples can be put into bags of 3, bags of 4, bags of 6. That is also another clue to tell you that you can use multiples. Alright, so we come to the end of this heuristic lesson. So stay tuned to the next lesson, and we will continue to focus on the different kinds of heuristics that we can use to solve different types of problem. Alright, so see you in the next lesson.